Welcome, class, to Lesson 4-10, Day 2. Today, strong mathematicians can identify factors and multiples in prime and composite numbers. So we got our factors and multiples from yesterday, which is going to help us today as we learn about prime and composite numbers. So with that, let's get to work. So take out your pencil, your notebook, write today's date, write the name of the lesson, and with that, we can get started. So what is a factor pair? A factor pair is two whole numbers whose product is that number. So notice an example, 2 and 5 is a factor pair of 10. So we need to find what are factor pairs. So it's two numbers when multiplied together make a different number. That's the factor pair. So the other two words we talked about are what is prime and what is composite. So a prime number is a number greater than 1 that has 1 and itself as its only factor pair. So it's really important that it's only factor pair. That means that, for example, 2, there's only one factor pair of 2, and that would be 1 times 2. 5, there's only one factor pair, 1 times 5. 11, it's only 1 times 11. 23, 1 times 23. So you're getting the hang of that. A prime number has only 1 and itself as its only factor pair. A composite number, on the other hand, is a number that is greater than 1 that has more than 1 factor pair. Some composite numbers are 4, so what can make 4? What two numbers can make 4? Well, 1 times 4, 2 times 2. So those are two factor pairs that we can get the number 4. Number 12, well, we have 1 times 12, 2 times 6, and 3 times 4. So some numbers can have 2, can have 3, depending on how big your number is. They can have a lot of factor pairs that go into certain numbers. So if it has more than 1, though, we know that it is a composite number. So you can pause the video right now. You can write down these definitions. It'll be very helpful to make sure we keep them straight, what's prime and what's composite, and what a factor pair is, so it can help us define our factor pairs as we go through today's lesson. So now what we need to do is list all the factor pairs for 24. And then when we're done finding all the factor pairs, is 24 a prime or composite number? That's what we're going to try to figure out. So what I was going to do with any factor pair that's under 100, I like to write the numbers down. 0, actually don't even need the 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The reason why I do this is because if we have any of these numbers and we times them by the biggest number, we can go anywhere from 0 to 100 and figure out, is that number part of a factor pair for 24? So the first one we always start with is, we can look at, I should always put 1. 1 is always a factor pair for any number, whether it's prime or composite. 1 is always a factor pair. So I have 1 times 24 equals 24. So that's a factor pair. Everyone's going to have 1 times itself. The next one I look at for, does my number end, the 1's digit, end in a 0 or a 5? Because if it ended in a 0 or a 5, we know 5 could be possibly a factor pair, or 10 could be a factor pair. So since it ends in a 4, I know 5 cannot be a factor pair. Either can 10. The next thing I look for is my number even or odd? Well, 4 is an even number, so since it's an even number, I know all even numbers. We can times them by 2. So 2 times what equals 24? If I'm not sure, I can go 2 divided by 24. 1, 2, 0, bring down the 4. 2 can go into 4 2 times. 12. So 2 times 12 is 24. So I can cross off 24. That's another one that makes it. I can get rid of the 0. I don't know why I put that one on there, because 0 times anything would give us 0. So now I'm left with these numbers. So if 2 is a factor pair, I should really check to see if all of my even numbers could be factor pairs. So the next question is, can 4 be a factor pair? Well, if I go 4 divided by 24, do I get another whole number? Well, 4 going to 24, I believe 6 times. Yep, look at that. 0, so it has a remainder of 0, so we know it is a factor pair. So we have 4 times 6 would be another factor pair, which is nice because then I can cross off the 4 and I can cross off the 6 because both of those will work. And last but not least, I can now try the 3. A cool trick that we learned for the 3 is I can do the same thing. I can always take the number and see if it's a factor pair by dividing. Or something that we learned is pretty cool. If you take this number plus you take the place values by themselves and you add them together, that equals 6. If you can divide 3 by 6, then 3 will be a factor pair. That's some crazy math thing that works. Kind of that cool tidbit. But if you're not sure, you can always go back to the 24 and the 3, divide in there. We get 8. So we know 3 times 8 is another factor pair. We got lots of factor pairs for 24. So I can cross off 3 and I can cross off 8. That leaves me with 7 and 9. So with 7 and 9, there's really not a good way to find if that works. So you really just got to think of, I can either do multiples of 7, multiples of 9 to see if either of those actually are pairs. So I can go 7, 14, 21, 28. Nope, not in there. So I know 7 can't be a factor pair. Or their strategy you can always take is 9 divided by 24. 9 divided by 24, it would be 2 with the remainder of 6. So that would not be 1 either. So the factor pairs for 24 are 1 times 24, 2 times 12, 4 times 6, and 3 times 8. So you can pause the video down, write these factor pairs. I would listen to this all again because it's a whole kind of a new process of how to figure out what a factor pair is. And before we move on to the next one, I have to answer my last question. I did the first part. Can't forget the last part. Is 24 prime or composite? Since it has more than one factor pair, it has 4 of them, it would be a composite number. Now you can pause the video, write all this down before we move on to the next one. And list all the factor pairs for 100. Whew. Here we go again. So that same strategy. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And with that, let's get started. So hopefully remember before, the first thing we do is we write down 1 times 100 because we know 1 times the number itself will always give us the first factor pair, whether it's prime or composite. Now the next thing we looked at is we looked at the last number to see, is it ending in a 0 or a 5? It does. So that means, since it ends in a 0, we know 2 things are going to take place. 1, 5 is a multiple, and we also know that 10 is going to be a multiple. So now you figure out 5 times what equals 100, and 10 times what equals 100. Well, easiest way to do that one, well, hopefully we know the 10 times 10, since we've been talking about place values and multiplication for a long time. And I'm not sure what 5 times what equals 100. We can always take that number and divide. 5 can go into 1, nope, it can go into 10 2 times. 5 times 2 is 10, subtract, bring down the 0. 5 can go to 0, that'd be 0, so 5 times 20. So right now we already have 3 factor pairs. So I can cross off my 5 now, cross off my 10, and we'll move to a different color. So now we look at the next part is it an even or an odd number? Well, that 0 is part of the evens, like 0, 2, 4, 6, 8. So that means we know 2 would also be a factor pair. So we can take 2 divided by 100, or we think of what is half of 100, which would be 50. So with that, 2 times 50 would be another factor pair. So we can cross off 2 now, because we have that one. If 2 works, then we got to see if the other even numbers work, right? So can 4 be divided by 100 evenly? Well, 4 goes into 10 2 times. 2 times 4 is 8. 2, bring down the 0. Can 4 go into 20? 5 times. 5 times 4 is 20. And left with 0. So yes, 4 times 25 can also equal 100. So that's good. So notice finding factor pairs is just very systematic, and I could go through all the numbers to make sure that they work. So we go to 6. Can 6 go into 100 evenly? 6 goes into 100. So we got a 1, 6, 4, 0. That would be 636. So it looks like it's not. Remainder of 4. So that would not work for us. Does 8 work for us? 8 divided by 100. 8 can go into 10 one time. 8 times 1 is 8. 2, bring down the 0. 8 can go to 22 times. 16, remainder of 4. Nope, remainder, it will not work. So that doesn't work as either. So what about 3? 3 is one of those common numbers that usually gets missed because 3 can be a multiple of lots of things. Because every third number, 3 would be a factor pair for. 3 divided by 100 would be a 3 here. This would give us a 9, a 1, bring down the 0. 3 can go to 10 3 times again. That would be 9. That would leave us with a 1, so remainder of 1. So 3 is not a factor pair. So do the same thing with 7 and the same thing with 9 to see if these are factor pairs. But we know if 3 is not a factor pair, the real cool thing is 9 can't be a factor pair because why? 3 is a multiple of 9. Something to keep in mind. So if 3 is not, then either is 9. Or if you find out that 9 is, then 3 needs to be as well. So it works both ways. 7 can go into 10 one time. Subtract. That's a 3, 0. 7 can go that 4 with a remainder of 2. So that'd be 28. And that'd be 2. So 7 is not. So our factor pairs for 100 are 1 times 100, 5 times 20, 10 times 10, 2 times 50, and 4 times 25, which means this is a composite number. So you can pause the video right now, even re-watch it, and go through all the steps to make sure that you kind of get the process we're developing to make sure we check all the numbers from 1 through 10 to see if they're factor pairs for a given number. And we're going to do one more. Why? Because we really like these factor pairs. So list all the factor pairs for 91. Is 91 prime or composite? So, as we said, hopefully you develop strategy. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the first one you're saying should be 1 times, over here, 1 times 91. That would work. So 1's down. So you know all numbers have 1 end itself. The next one, does it end with a 0 or a 5? The answer is no. That means 5s cannot be 1. Either can 10. Then we look, is it even or odd? It is odd, which is nice because if it's odd, then all the even numbers of 2 and 4 and 6 and 8 cannot be factor pairs. So now I'm left with 3, 7, and 9. So can 3 go into 91? 3 go 91, 3, that'd be a 9. 0, bring down the 1. That'd be a 0 with a remainder of 1. So 3 cannot be a factor pair. Which you know, if 3 can't be a factor pair, we know 9 can't be a factor pair. Because remember, 3 is a factor of 9. Which only leaves us left with 7. So let's test. Can 7 go into 91? What do you think? Yes or no right now? Let's find out what your guess was. 7 can go into 9 one time. 1 times 7 is 7. 2, bring down the 1. Oh, 7 can go into 21. 3 times 7 times 3 is 21. 0, so yes, we found one. 7 times 13 equals 91. So you don't give up on numbers. It might be the last one you try to see if you've gone through them all. So this number would be a composite because it has more than one factor pair. So you can pause the video again and go through them. Remember some of those little tips we're starting to give you. Hopefully you listen to them over and over. Hopefully it'll help them sink in. You can draw a big line on your paper. Box 3, now your turn. Write the number 48 on top and list all the factor pairs. Go through that strategies that we worked on and then tell me if it's prime or composite. Pause the video right now and good luck. And the next one you can work on is 51. So is 51 prime or composite? So you can pause the video, go through them all the steps, and good luck. And last but not least is 96 prime or composite. List all the factor pairs and good luck. See, it's a lot of practicing the skill over and over to help you feel comfortable finding factor pairs. As always, if you have any questions, comments, or concerns, feel free to put them down into box 4. Also, if you learn any other strategies that can help you, make sure you share those out as they may help other students. And always, thank you for a great lesson.